Hello everyone, welcome to Vijay Codes It. Today we are going to start a new series on Apache Spark. So you guys might have one question, what exactly is this Apache Spark? So Apache Spark is a unified computing engine and a set of libraries which is used for parallel data computing on a computer cluster. So when you Google what is Apache Spark, this is the definition that we get. But it is kind of complicated to understand. Let's break it down. Unified. So unified in a general English means like to bring something together. But in a Spark context, Spark is bringing three different professions: data analyst, data engineers, and data scientists to work on their data modeling and transformations using Spark as a single platform. Computing engine. People tend to think that Spark is a storage thing, but Spark is basically used as a computing engine. Spark does not have the ability to store things, but it gives us the flexibility to store things over the cloud. We can use Spark and store data in S3, Azure Storage, etc. Now let's understand what does parallel data processing means. Parallel data processing can be understood with the help of an example. Let's assume that you are in a grocery store and you are in a queue for billing. You are at the 10th position. So there are 9 people in front of you, and your turn will be coming after this 9 people are done because there is only one cashier. And at that time, you think that what if there were multiple cashiers? So if there are multiple cashiers, assuming there are 5 cashiers, your turn would be like second because you would be standing in groups of two. That's how the task is divided using Spark. Spark basically divides the job so that it is done in way faster. So now we understood what parallel data processing is. Now let's understand what computer cluster is. So Spark is basically based on master worker architecture. So there is one master node and multiple worker nodes. I should try worker nodes in a different color. Give me a moment. Okay. So there are multiple worker nodes. Let's assume that the storage capacity or the RAM for each of the worker node is 8 gigabytes. Now you have to like compute 5 TB of data. So what this master node would be doing would be taking 5 TB of data, dividing it into chunks, and it would be transferring 8 gigabytes of those chunks to this worker nodes. And this worker nodes would be transforming those 8 gigabytes of data and giving it back. And once the worker node is empty, the master node would be sending more data to transform. That's how master node keeps each and every worker node busy and occupied, and hence it is fully utilized. And we can process like 24 gigabytes of data simultaneously. So now hope you are able to understand the definition that Spark is unified. Everybody can use Spark who is working with data. And it is a computing engine, not for storage, which can be used for parallel data processing on a set of computer cluster. Now we have seen that what is Apache Spark. Now let's see why Apache Spark. In the earlier days, we used to have databases like Oracle, Teradata, MySQL, etc. And this database is used to store only the structured data, which is in a tabular format. Here is an example of it. But after the internet, we started getting semi structured and unstructured data in the form of JSON, YML, videos, photos, etc. But these databases, these traditional tabular databases, weren't capable of storing all these things. Also, after the internet is viral, we are generating huge amounts of data. So let's study the concept of big data. So what exactly is big data? Big data is something like which you cannot fit into your computer. So when you will term a data as a big data, if the size of data is 10 GB, no. If the size of data is 100 GB, would you term it as a big data? No. If size of the data is 10 TB, would you term it as big data? No. So when you will term a data to be big data, so it totally depends on three V's of data. So the three V's of data are big data are volume, velocity, and variety. So if you have 10 TB of data generated at per second, per minute, per hour, so that's when you will term it as big data because you are generating 10 TB of data in per second, per minute, or per hour, and variety in various formats like structured, semi-structured, and unstructured data. So if your data is having all these three problems, that's when you will term it as big data problem. So now, since we have understood what is big data, now let's understand more history behind it. Earlier, we used to use ETL. It is extract, transform, and load. It is still used. It's not kind of extinct, but still used. So what we used to do is like in ETL, we first extract the data from the source, which can be anything, a database, a website, or anything. We extract the data and do a process on it. We run a pipeline, we transform it, and then we load it into a data warehouse, which is a structured data, and people can query this database, data warehouse to get the data. We have the pipeline in over here where there will be a different processes, and it takes like multiple steps to reach out to this final form. But now we use mostly use ELT because the data is so big that we do not have the time to process it. So ELT stands for extract, load, and transform. In ELT, what we do is like we extract the data from the source and we directly load into a data lake, which supports all kind of data, structured, semi-structured, and unstructured data. And then we transform on it as per the requirement, and directly the end user can query the data lake using Spark. Now, as we are familiar with ETL and ELT, let's understand the issues. To process the data, we require more storage since the data is growing at an exponential speed. The first issue is that we need more storage, and the second issue is processing. And to tackle these issues, we have two options. The first one is monolithic, and the second one is distributed. So in monolithic, we have like a single machine and we keep scaling it vertically. So what exactly is vertical scaling? Say you have a single machine with 8 gigabytes of RAM, but suddenly the size of your data becomes 10 GB, which is greater than 8 gigabytes, and you cannot fit it into your CPU or RAM. That's when like you take out this 8 gigabytes and replace this 8 gigabytes with 10 GB. and you keep on doing this same process and you keep on buying new hardware to like fit in your data into a single machine. But in distributed, what we do is like horizontal scaling. Here, if we have a single machine of 8 gigabytes, and if the data is greater than the size of our processing or storage unit, we just add another single unit of the same capacity, 8 gigabytes, and we keep on adding it until the data fits into our system. The drawback of monolithic is that it is a single point of failure because we just have one single node. And if this nodes fail, our system is totally down and our client won't be getting the responses. Client or the end user, whosoever is working on the downstream querying the database or data lake. In case of distributed system, even if a single node is down, the worker node, the master node who is like sending data to this worker node would be like sending data accordingly to all of these different worker nodes. So it is like highly available. The monolithic architecture is very expensive as we keep buying new and new hardware and we are not using the old hardware over here. But in distributed, since we are buying only like the same capacity, it is not that expensive. We are not like throwing away the older 8 GB which we had. We are still using it continuously. So hence due to this thing we it is cheap, comparatively cheap. Hence due to this we use distributed architecture much more in this today's world. Hence distributed approach. So for solving this distributed approach thing, we the big data in distributed approach, we have multiple ways to do it. One of the way is using Hadoop, which is kind of extinct in today's world, and it has evolved. And today we use Spark. So this is why we use Spark today, and we will be studying comparison between Hadoop and Spark in our next lecture.